Quiz 5, there are 20 problems. We're going to try to solve each and every problem spending less than 1 minute. The problem number 1, you move 20 meter to the north, and then remember this one, this is north, this is south, this is east. So you move northeast 30 degree. So 30 degree means there is a invisible x-axis. So this is 30 degree northeast. So then make it longer because this is double 40 meter. Now never forget to make it a parallelogram. So that's it, that's a parallelogram. So if this is 30, then that's 60, then this is 120, then this is 120, this is 60. So this is parallelogram. What are you actually looking to find? You're looking to find the resultant. This is the resultant. What is the resultant? That is r squared is equal to a squared plus b squared plus 2ab cosine 120. Parallelogram, you have to use the angle between tail and tail. So r squared is equal to 20 squared, which is 400, plus 40 squared, which is 1600, plus 2 times 20 times 40, and then cosine 120 is negative half. Negative 2 goes to 40, just 20. So you have r squared is equal to 400 plus 1600 minus, there is a minus, so you're going to put minus 20, 20 is 400, 800. So r squared is equal to 400 plus 800. So r squared is 1200. So r is square root of 1200. So r is 34.64. So now I ask you to show me 2 sig fig. So you're going to show me 2 sig fig. 35 meter. This is the answer. If you want to write east, that would be great. That's problem 1. Now let's go to problem 2. Problem number 2, let's first make a story out of problem number 2. You experience, you see, you observe 2 balls falling, hitting the ground with same impact velocity. 2 balls from 2 different height, one known and one is unknown. So this is the story of problem number 2. This is unknown, we're going to call it h, and this is known, we're going to call it 20 meter because we know it. This both initial velocity is known. However, the good thing is the both object hit the ground with same impact velocity. Final velocity is the same. So what are you going to write? VA squared is equal to VI squared plus 2AD. And the same thing over here, VB squared is equal to, because this is ball A, this is ball B, VI squared plus 2AD. Hopefully you see over there. So VA squared is equal to, VI is given. All right, so you throw the ball with 20 meter per second, right, at 90 degree at the y direction. So you want to write 20 squared, which is 400, plus 2 times, of course, negative 10, and D is known, negative 20. So you have VA squared is equal to 800. Okay, so VA squared and VB squared has to be the same because the both ball hit the ground with the same impact velocity. So I'm just going to write VA squared is equal to VB squared. They are the same. So I'm going to write VA squared over here. But VI is given because you drop this ball. Drop this ball means initial velocity is 0. Plus 2, negative 10. D is H. That's what you try to find, H. So VA squared is 800. So you're just going to replace it. 800 is equal to 20H. So H is equal to 40 meter. Okay, so we know now this is 40 meter. So in fact, this is double the height. All right, 2 kilogram mass. This is a motion of 2 kilogram mass. What's going on? I'm just going to show you the displacement versus time from, I don't know, from 0 to 6 seconds, because beyond I ask you information about 5 seconds. So I'm not going to go beyond 6 seconds. Oh, I totally forgot. I have to tell you the story. So the story is a 2 kilogram object is started moving, right? Fast 2 seconds, it moves with constant velocity. So let's convert my story to math. All right, fast 2 seconds, it moves with fast 2 seconds, it moves with constant velocity, right? 2 seconds, it moves with constant velocity, covering the distance of 2 meters. Next 2 seconds, it doesn't move at all. It is at rest. Next 2 seconds, it is at rest, covering nothing, covering no distance. And next 2 seconds, it is speeding up. Next 2 seconds is speeding up. So it is speeding up, is speeding up. So covering additional 2 meters. Next 2 seconds we don't care because I ask you the information about the at 5 seconds what is the net force acting on the object at 5 seconds. So we don't have to do 4 to 6. But if you want to do 6 to 8, then you know that at 8 the velocity is 0 because it's turning. So this is covering additional 1 meter. But we're not going to do beyond this one because I want to finish this tutorial as soon as possible. Now we know at 5, right? This is what I ask you right here, right here. So we're going to convert this to VT graph. If we do convert to this VT graph, what do we get? This is diagonal line, so the slope of this one is velocity. So 2 divided by 2 is 1. Okay, so this is 1. All right, now this one velocity is 0 because the slope is 0. So we're just going to say the velocity of 2 to 4 is 0. So velocity is 0. This is 1, this is 0. So far so good. Now from 4 to 6 is problematic, right? 4 to 6, this is 4 to 6, this is 5. 4 to 6 is a curve, a positive curve. Positive curve means a slope of a positive curve is a diagonal line. The diagonal line, area of a diagonal line is half BH. So area is half BH. So what is area? Displacement half B. What is B? Time. What is H? Velocity. What is the D over here? 4 minus 2, which is 2. Half. Time is 6 minus 4, 2. Velocity. 2 to cancel. So velocity we discovered is 2. So you're going to write velocity, but it's going to be diagonal line. So you're going to put a dot over here, right? And we're going to draw over here, and we're going to put a 2, carefully put 2. Now we're done with converting the DT graph to VT graph. Now we're going to convert it to AT graph. And what we're going to discover by converting it to AT graph, we discover that the slope of this one is 0. So 0 to 2 second, 0 to 2 second is the slope is 0. 2 to 4 second, the slope is also 0. But 4 to 6 second, slope is not 0. Let's see what is slope. The slope is acceleration is Vf minus Vi over Tf minus Ti. What is Vf? 1. What is Vi? 0. What is Tf? 6. What is Ti? 4. I'm sorry, 2. Or Vf is 2. So 2 over 2. So this is 1. Acceleration is 1. Now all about Newton's second law. Newton's second law is F equal to ma. F is equal to the mass is 2. A is we found 1. So F is equal to 2 Newton. Problem number 4. What is this study? This study is constant velocity. How constant velocity is this study? Because the net force is 0. Acceleration is 0. That's how constant velocity is a study. Not only one study. In problem 4, there are 2 study. You have, I did not give you the mass in terms of kilogram. I give you the mass in terms of Newton. So that's in itself is a study. So I give you a mass, 100 kilogram, 100 Newton. So 100 Newton, you don't, this is not mass, this is weight. And this guy is moving, applied force is 50 Newton. So there are 2 studies. Study number 1, it moves with constant velocity. So constant velocity means acceleration is 0. That means all the forces acting at x direction cancel each other. But do you see they cancel each other? No, you don't. Because now the way it does look, they don't cancel. It's not constant velocity. Why? Because there is a net force to the east. Now, to make it constant velocity, we have to cancel this one, 50 Newton. You're going to write 50 Newton. What are you going to call it? This is equal in magnitude, opposite in direction. What are you going to call it? Of course, FF. Okay, there you go. Now, another story is I did not give you the mass, but I gave you the weight. You don't need to, I don't need to give you both. If I give you weight, you can divide by 10 and get the mass. So mass of this one, if you really want a mass of this one, divide by 10, acceleration due to gravity. So you get 10 kilogram, but you don't need it. This is Fg is 100 Newton because mass is 10 kilogram. and Fn is also 100 Newton. Okay, now what do you want to find? We want to find mu k. Now, to find the mu k, you have two equations. Ff is ffs and ffk. Ffs is mu s fn and mu k fn. Which one are you going to use? 50-50 chances? No, of course. The object is moving, so you have to use this one. So you're going to use ffk is equal to mu k fn. What are you looking for? Mu k. So mu k is fk over fn. So fk is 50 and fn is 100. So that means mu k is 0.5. Mu k doesn't have any unit because this one is Newton, this one is Newton. They cancel each other. And that is problem number 4. Now let's go to problem 5. The problem 5 is they come from the do now, right? You remember problem 5 came from the do now. What is that? You want to you don't like 9.8. Acceleration due to gravity negative 9.8 bothering you. Why is that? Because this is an ugly number. Why is that? Because this is decimal. Why is that? Nobody likes decimal. What do you want? You want acceleration due to gravity 10. Wouldn't it be nice to have acceleration due to gravity is just negative 10 meters per second squared? Okay, great. So what are you going to do? You're going to write F is equal to F. Then you're going to write Fg is equal to Fg. Then you're going to write Mg is equal to G M1 M2 over R squared. Why they are the same? Because hey, SI unit this one is Newton, 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 SI unit for this one is Newton, SI unit for this one is Newton. Now guess what? Is small m, I'm going to make it big M. Is small m cancel. Now you have G is equal to G big M over R squared. Now you want to change the mass, you don't want to change the gravitational constant or radius. So you want to write G is equal to big M. G over R squared, you don't want to change them. Still left hand side is equal to right hand side. Left hand side meter per second square, right hand side meter per second square. Okay, so G is, so we're going to say G, M, M. So we're going to say G old, G new, M old, M new. So what is G old? We know G old, which is negative 9.8. What is G new? We want negative 10. M old, we know 6 times 10 raised to 24. M new, we want to find it. Okay, great. So X is then what? 9.8, negative cancel. And you have 6 times 10 raised to 25. So X is 6.12 times 10 raised to 24 kilogram. What is X? New mass. All right, make sure you give only 2 sig fig. This time I was very nice and generous. Exam 5 on Friday, I won't be as generous because it takes forever for me to finish those grading. Right now, for example, it's 3 in the morning. So make sure I ask 3 sig fig, you give 3 sig fig. Okay, let's go to the next problem. Problem number 6. Problem number 6 is very simple. I give you, again, the studio problem 6 is, hey, I did not give you the mass, I gave you weight. But why do I have to give you mass when I give you weight? So what weight I gave you? I gave you 150 Newton. Okay, by knowing weight, you know the mass. How? Divide by 10. So the weight is 150 Newton. So mass is 15 kilogram. If you feel good by writing this one, feel free to do that. I don't care. I give you scrap paper. You write whatever you want. Good. You pull this one by 100 Newton and you pull this one by, well, there is a friction, by 50 Newton. So friction is pulling this way, but there is a net force to the east because 100 is bigger than 50, obviously. Fg is 150 Newton and Fn is also equal in magnitude, opposite in direction. Good. What we are trying to find? Acceleration. Acceleration is Newton's second law. A is equal to F net over m. F net is 100 minus 50, 50. M is 15. So acceleration is 3.333 forever. However, I asked for 2 sig fig. I did not ask for 3 sig fig. 2 sig fig meter per second square. What is this to do for problem 7? There is a box. You want to move, applying 15 Newton. Let's consider 3 scenario. Same box. Box with mass m. Box with mass m. Box with mass m. You apply some Newton. You apply some Newton. You apply some Newton. You apply 0 Newton. Velocity obviously going to be 0. Friction going to be obviously 0. You apply 15 Newton and you realize that it doesn't move. So friction not going to be 0 anymore. Friction is going to be 15 Newton because it's opposing, friction is opposing on the other direction. If you apply 20 Newton and you realize that box doesn't move, then of course the friction is 15 Newton. Or 20 Newton. Friction is 20 Newton if box doesn't move. Okay, great. What is the studio problem number 8? What is the angle has to do with acceleration? If you increase the angle, acceleration decreases. If you decrease the angle, acceleration increases. Let's consider 2 scenarios. Scenario 1, scenario 2. A box, I don't know, 10 kilogram, make it up. Apply, I don't know, 60 Newton. FA is 100 Newton. 100 is a nice number at 60-degree angle. Same box, 10 kilogram. You decrease the angle from 60 to 10. However, you keep the same. So acceleration in this case is going to be 5, no friction. Acceleration is going to be 5 meter per second squared. In this case, acceleration is going to be double, 10 meter per second squared, or approximately double, very close to 10. So what do you see? Decrease angle, acceleration increases. Angle go down, acceleration go up. Takes us to problem number 9. What is this story? Story is I gave you 2 vectors and you have to do draw the parallelogram. Start from x and y axis. The vector A is 10 degree below the x-axis. The vector A is, not vector A, the resultant is, I don't know, also 10 degree above, more or less 10 degrees. So I'm going to erase this. I don't need this anymore. These are distracting now. So these help me to draw it. Okay, this looks too long. It should not be that long. So I ask you to show the B that causes this resultant. How? By parallelogram. Draw this vector A. So this vector A. So draw an x-axis over here. And this is negative 10, negative 15. Who cares? Okay. All right. You don't need that anymore, x-axis. Okay, because you're done with the vector A. So you're going to call vector A or A prime. Okay, now you can draw B. So to draw B is this one. So this is B now. Okay, so this is B. So now you see that this is a nice parallelogram and this is the resultant. A resultant is from, when you see resultant is tail to head, then you know this is the resultant. So problem 10. So problem 10 is 600 Newton, apply 200 force. So 600 Newton who? Me. How am I 600? Because I'm 60 kilogram. What makes me 600 Newton? Because I'm a mass, force acting on me. 60 times 10. So 600 Newton. I'm 600 Newton. What am I doing? Applying some force. How much? I don't know. 200 Newton. I push this board with 200 Newton. Board applied 200 Newton to me. Equal in magnitude, opposite in direction. 11, 2 Newton box is resting. Friction graph is given. Some information is given. Okay, so what do you know that? This is mu k. What do you know that? This is mu s. This is mu k fn. This is mu s fn max. At right here. Okay. Anyway, So the box is resting, right? Some force applied to the box and the box is moving. Find the mu k. To find the mu k, of course, you're going to do what? F is equal to F is equal to mu s Fn mu k Fn, right? You know the box is moving means you have to use this one. When you use this one, what do you get? Mu k is equal to Ff over Fn. So now if this is 2 Newton, this is 0.2 kilogram, by the way. 0.2 kilogram times 10 is 2 Newton. So Fg is 2 Newton. Fn is 2 Newton. So Ff is 0.9 and Fn is 2. Okay. Is 0.67, mu s is 0.5. So this dry asphalt is like a concrete. Okay, so the driver hit the brake. When the driver hit the brake, what happened? Wheels, the friction acting on the wheels, right? And friction slow it down, and eventually the car is stop at location B from location A and is skidding, right? Is it stop right here with final velocity, and initial velocity was not zero. After hitting the brake, initial velocity eventually at location B get to the zero. And the distance from A to B is 16 meters. We don't need that. We want to find out friction that causing this halt. So the friction that causing this halt, so Ff is equal to Fk Fs, right? So this is mu s Fn, and this is I don't know mu k Fn. So this is the car, right? 1200. So this is 12,000. This is Fg. This is Fn, also 12,000, right? Equal in magnitude, opposite in direction. Okay, so now the car was moving while it was slowing down and stopping. So we have to use mu k, not mu s. So Ff k is equal to mu k Fn. Okay, so then F is mu k is 0.67, right? 0.67 times normal force. What is the normal force? 12,000. Okay, so I ask you to give me in one sig fig. So 8 times 10 raised to 3 Newton. Okay. 8 times 10 raised to 3 Newton. I asked you to give me sig fig. So this is one sig fig. Okay, one sig fig. Follow the direction. Let's do problem number 13. Problem number 13 is G is, if you write G is negative 9.8 meter per second squared, I'll mark it wrong. Why is that? Because this is not what I was looking for. This is not what I asked. I did not ask you to give me acceleration due to gravity. Of course, this is very close to what I asked for, G, okay, which is negative 9.8, which is Newton over kilogram. So you can say this is almost the same. Okay, almost the same and same are not the same thing. So this is the convention. We have to follow the convention. So let's follow the convention, and so let's strictly follow my instructions. Okay, now do you have to memorize it? No, you don't. Did I memorize it? No, I don't. Okay, so let's derive it. So what do you call it? Gravitational field. So when I write G is equal to negative 9.8 meter per second squared, this is acceleration due to gravity. This is called acceleration due to gravity. When I write G is equal to negative 9.8 Newton over kilogram, this is not acceleration due to gravity. This is gravitational field. Where did the equation come from? Here. F is equal to F. Nothing can go wrong with that. Fg is equal to Fg. Also nothing can go with that. Mg is equal to G, big M is small m over r squared. Also nothing can go with that. Because this is Newton, this is Newton. Cancel. So G is big M over r squared. How do you know this is meter per second? This is Newton over kilogram. This is Newton over kilogram. You know it. This is Newton. G is Newton. Meter squared over kilogram squared. And then you have meter mass, which is kilogram. You have r squared, which is meter squared. Now, if you look inside the Newton, you see kilogram meter per second square, being down meter square, being down kilogram, being down kilogram square, and being down meter square. And you want to see lots of things going to cancel out. Meter square cancel. Kilogram goes to kilogram square just once. So what are you going to have? You're going to have kilogram meter on the top. On the bottom, what do you have? Kilogram second square. Kilogram second square. Now, kilogram meter per second square itself is a Newton. So Newton over kilogram. There you go. So we prove that. Okay, in the future, we're going to prove that this is actually 9.8. In fact, you can prove it right now at home. So G is 6.67 times 10 raised to negative 11. M is 6 times 10 raised to 24. And R is 6370000 square. So G, this is 9.8. We proved that. Okay, there you go. That was problem number 13. Let's go to problem 14. So what is this studio problem 14? I ask you construct a parallelogram. All right, so you're going to go 20 Newton. I don't know what I gave you, but let's say I gave you 20 meters. Doesn't matter. All right, so then you're going to draw an x-axis and 60 degree with respect to x-axis, right? Because I said this is north, this is east. So I said move northeast 60 degree. So move. All right, so this is 40 meters. Okay, so this is vector B. So this is vector A, this is vector B. So what is A prime or B prime? Let's draw B prime. The B prime would be this one. This one would be B prime. Okay, if you have the x-axis over here, this is 60 northeast. Okay, and this is your A prime. A prime, this is your B prime. So this is the resultant vector. Now if this is 60, don't forget this is 30, right? Because 30 and 60, 90. Then this must be 150 because 150 and 30 is 180. And then this must be 150 and this must be 30 and this must be resultant. Okay. All right, there you go. So that is that, and that is problem 14. Let's do problem 15. Problem 15 is, what did I ask you? I asked you is similar to problem number 3. I gave you the DT graph. The DT graph 1, 2, 3, 4, 5. The time measured in second 1, 2, 3, 4, 5. This is 2, this is 4, this is 6, this is 8. So something going on in this graph, right? So 2, so at 2 seconds the object move 4 meters. Next 1 second object at rest. Next 1 second object is slow down. Next 1 second, all right, so it's speeding up and slow down. Okay, that's what's going on. This is the maximum velocity, and that's all right. This is speeding up again. Okay, all right. So velocity here, speed here, the same. Okay, so now you're gonna do a VT graph. How do you do it? Okay, you're gonna do it by doing it. 4 divided by 2 is 2. So this is 2. Now you see the slope of this one is 0. So you're just gonna draw 0. You see the slope of this one is a diagonal line, but this is, yeah, what happened this one? This is max and decreasing 0 and increasing. Okay, well the magnitude is increasing, but the velocity is decreasing, speed is increasing, whatever that means. Okay, so the displacement, what is the distance? From 3 to 4 is 4, and from 4 to 5 is 4. 4 plus 4 is 8. So this is a curve. So curve gonna give you a diagonal line. If the curve does give you diagonal line, then diagonal line is, you did it million times. A is equal to half of BH. So 8. Why 8? Because the distance from 3 to 5 is 8. 8 minus 4 is 4, and 8 minus 4 is 4. So here is 4, here is 4. So 8 half. It move 8 meter spending 2 seconds. So velocity is 8. If velocity is 8 over there, velocity must be 8 right here. I mean negative 8. Okay, good. So if this is negative, this is positive 8, this is negative 8, because this is symmetric. Good. We're not gonna we're going to find this VT graph, what you call it, the slope. So the slope is, acceleration is VF minus VI, TF minus TI. So VF is negative 8, positive negative 8. Delta T is 5 minus 3, 2, so negative 8. Acceleration is negative 8. So the slope of this one is negative 8. That's what it means. So we're going to write y is equal to mx plus b. The most important point is 4 comma 8. No, absolutely not. We're not going to use this graph. We have to use this graph. Okay, so the point, any point you can take, this point you can take. At 4, the velocity is 0. So 4 comma 0 is a nice point. Okay, so this is x, this is y. So y is 0. When y is 0, of course, the slope is negative 8. X is 4 plus b. So we know y-intercept is 32. Now we know everything. So y is equal to mx plus b. So y is equal to negative 8. This is t plus 32. So this is v of t, not p of t, because we use this graph, and this graph is vt. So this is v of t. If we did use this graph, then it would be p of t. Now we use this graph, so this is v of t. So this is negative 8 t plus 32 at 4.5. I ask you 4.5. So negative 8, 4.5 plus 32. So this is v of t is equal to 36, negative 36 plus 32. So this is negative 4 meter per second, of course. So problem 16 is the most important problem. Why is that? Because it allows you to make connection between 4 different things. You want to see the connection between force, acceleration, velocity, and displacement. 4 simply different things. You're going to put them together by using problem number 16. All right, so what is that? You have a 20 kilogram object, 2 forces acting on it. Force A, which is 100 Newton. Oh, well, I can do it better. I can say this is at t is equal to 0, there is a box which is 20 kilogram. There is a force acting, A is 100 Newton. Then there is a force B, which is all 120 Newton at angle unknown. And at t is equal to 0, the displacement is 0. Now, the box at t is equal to 3 seconds over there, that means d is not going to be 0. In fact, d is happen to be 5. The mu k is 0.1, right? I want you to find what angle made this 5 meter possible. It's seemingly very easy problem. It is actually easy. All right, so it's step 1. We're going to write ax, ay, bx, by. Now you pause the video and do that. Okay, so ax is 100. Ay is 0 because a doesn't have y component. B has x component and y component. So 120 cosine theta and 120 sine theta. This step number 2. We're going to draw a free body diagram. Free body diagram, the easiest thing always is the weight. The weight is 200 Newton. Why is that? Because it's 20 kilogram. Fx is, you want to add them up. So 100 plus 120 cosine theta. Now, Fy is, you want to add them up. 120 sine theta. Normal force, 200 minus 120 sine theta. Don't forget to call it normal force. Ff is mu k Fn. Mu k is 0.1. Fn is this one. So 200 times 0.1 is 20 minus 120 times 0.1 is 12 sine theta. You're done with free body diagram. Now you always gonna, once you finish the free body diagram, you use Newton's second law. 3 F equal to ma, Newton's second law. All the forces acting at the x direction. Okay, we're gonna call F net because ma is equal to F net. Fx, so F net is equal to fx minus ff. Okay, so what is fx? 100 plus 120 cosine theta. 100 plus 120 cosine theta. Minus, so this is minus, you see that 20 minus 12 sine theta. You notice I made a mistake intentionally to kind of put emphasis on forgetting about distributing the negative sign. Okay, so this is our F net. So acceleration is F net over what? Mass. Mass is 20. F net is 100 minus 20 is 80 plus 120 cosine theta plus 12 sine theta. Now, acceleration is 80 divided by 20, of course, 4 plus 120 divided by 20 is 6 cosine theta plus this is 0.6. 12 divided by 20 is 0.6 sine theta. This is acceleration. We're going to do step 4. D is equal to half a t squared. Now, at 3 seconds, so D is equal to 4.5 a. Now, step 5, we know that 4.5 a is equal to D. So 4.5 a is 4 plus 6 cosine theta plus 0.6 sine theta is equal to D, which is 5. It's 2.7. This is 27 cosine theta plus 2.7 sine theta is equal to 5. So this is our step 5. Now we're going to go to step 6. To go to step 6, I'm going to take you over here. All right. So step 6. Remember, step 5 is this: 27 cosine theta plus 2.7 sine theta is equal to negative 13. Okay, so we're going to write dot product u dot v cosine theta minus p is equal to negative 13. What is going on over here? You probably think. Let me bring it closer. What is going on over here? You probably think. Well, let's explain what's going on. U is 27 comma 2.7. So the angle for this one is the theta is well, we're going to call it P. Let's call it P because we have two angles going on over here. P is tangent inverse 2.7 divided by 27. 2.7 divided by 27. So P is 5.7 degree. All right. Okay, what is V? V is cosine theta comma sine theta. Okay, so what is the magnitude of the V? The magnitude of the V is 1. How it is 1? Because cosine squared theta plus sine squared theta is equal to 1 in the unit circle. Okay, so the magnitude of V is 1. What is the magnitude of U? 27.13. Okay, great. Now, we're going to write V U, and that is step 6. Dot V, okay, cosine theta minus P is equal to negative 13, right? So you're going to write U is, we found it, 23.13. V, we found it, 1. Cosine theta minus mu, phi, 5.7. Okay, so cosine theta minus phi is equal to negative 13 divided by 27.13. So theta minus phi is equal to cosine inverse negative 13, 27.18, 13. So this is 118. So the theta is then 118 plus 5.7. So this is 124.33. I asked 3 sig fig. So theta is 124. What does that even mean? Okay, let's see whether I can give you some intuition. If you go to a unit circle and you draw, this is x, you draw u, where did I get u? Okay, what is x between x and u? Phi, what is phi? 5.7. What about v? This is v. What is the magnitude of v? What is the magnitude of u? Magnitude of u is 27. What is the magnitude of v? 1. Okay, all right, now we can find the angle, right? What is the angle? Angle is 118. So what is the angle from the vector A to vector B? 5.7, 118. See, we put them together nicely. 17 and 13 are the same thing. All right, so this is the gravitational field. The magnitude of gravitational field is 9.8, and the SI unit for gravitational field is Newton over kilogram. I proved it before, so I'm not going to prove it again. Check problem 13. I show you the proof where Newton over kilogram come from and where 9.8 come from. Problem 18, I give you, so there is a rope. This is ceiling. This is rope 1. This is mass. This is rope 2. So you're going to draw. What I did, I apply some force down the stairs. I grab it, I pull it down with 5 Newton. It's spending forever. Spending forever means that rope 2 was able to communicate with mass, was able to communicate with R1, and the breaking point, rope breaking point, is 6 Newton. The question is, you're going to draw a free body diagram and which rope will break. Very easy. Let's start with rope 2. Rope 2, okay, there is no mass to the rope. There is a mass, but almost zero, so we don't care. Fg, no, there is no Fg, so F pole is negative 5 Newton. So this was able to communicate with the, it was able to send the information. So F, we're not gonna say Fn, Ft, the tension force, okay? You pull it down, there is a tension. If you pull it down, there is a tension on the rope. If you pull it down, you will see the tension on the rope. That tension is 5 Newton, positive, because it's opposite direction. Okay, we're done with the rope 2. Rope 2 did not break because this is not the limit. Okay, so you're gonna now do mass. All right, mass, what's going on? Mass is Fg. Fg is, mass is 200 gram. So it's 2 Newton, negative. Pole, F pole is this one, actually, is 5 Newton, negative 5 Newton. So you're gonna say this one, Ft is 5 plus 2, 7 Newton. Of course, opposite direction. Okay, now what happened to the rope 1? So we're gonna go to rope 1 now. Okay, and the rope 1, Ft or F mass or whatever you want to call it, Ft from mass, negative 7 Newton. F ceiling or whatever you want to call it, Ceiling, ceiling is positive 7 Newton. Now wait a minute, this is finishing the free body diagram, allowing us to see that this rope did not break, but this rope broke because 7 is bigger than 6. So this rope snaps. Okay, that was problem number 18. Let's do problem 19. So what happened? You are on the top of a 50-meter cliff. What do you want to do? This is 0 meter. So this is 50 meter. You are on top of here. You are here. You want to jump. Not here. Not here. Not even here. So here is 90 meter. So here is, let's say, 40 meter. Here is 100 meter. So you don't want to jump. You don't want to land at 40 meter. You don't want to land at 100 meter. You want to exactly land at 90 meter from the wall. So how can you solve it? You know that right here, when you off the rooftop, the velocity has two components, Vx and Vy. Vy is 0. What Vx will allow you to land at exactly 90, but not 40 or 100. So d is equal to dx and dy. Dx is Vixt and dy is Viyt plus half Ayt square. This one goes to 0. So this one is 50 or negative 50, and this one is 5t squared. So negative negative cancel. 5 goes to, so t squared is 10. So t is square root of 10. All right, so it's 3 something. So then you want to find this one. So Vx is what? Dx over t. So Vx is now, dx over t. Do we know dx? Yes, 90. All right. Do we know t? T is square root of 10, which is 3.2. I don't know. So 90 divided by 3.2 is 28 something. But I ask you for 2 sig fig. So 28. 28 what? Meter per second. So you have to leave the rooftop with Vx 28 meter per second. So you don't land here, you don't land there, you land here. Okay, the last problem, 20. Thank God, it's 4 in the morning. Okay, all right, so 20. Okay, 1, 2, 3. I gave you 3 scenario, but the good thing is you see 3 balls falling. Okay, 1, initial velocity is 25 meter per second, 90 degree. 1, initial velocity is 0. That means it is dropped. 1, initial velocity is Vi is negative 25 meter per second. That means it is throwing down. This one, height is, I don't know, 30. This is 180. This is 330. The good thing is they all fall at the same time. Okay, so T1 is equal T2 and T3 is the same thing. So which one would be the easiest to find? This one would be the easiest to find because it's free fall, it's drop. So if you know T2, you know T1 and T3. There you go. So you're going to find T2. How can you find T2? D is equal to half AT squared. D is 180 is equal to 5t squared. 5 goes to 180. 3, so 36 t squared. So t is equal to 6. So T1 is 6, T2 is 6, T3 is 6. Answer is 6. That was 20. Very easy. I'll see you tomorrow. Well, today. It's 4 in the morning.